Welcome. This is section 2.2. We are finally doing the regular derivative. We are finding the regular derivative. Basically the shortcut, right? The shortcuts. We're taking the shortcuts. All right, the constant rule. Constant rule meaning if we're taking the derivative of a constant, the derivative is zero. This was one of those forms I had warned you about. We talked about this when we first talked about derivative, and I'm talking about this form. When they put ddx and they put a box around the thing you want to take the derivative of. So this is a way to explain the rules of differentiation. So the derivative of a constant. So if I take the derivative of 5, it's 0. Or if I have f of x equals 7, the derivative is 0. So that's what that means. All right. Next one is power rule. Power rule is a very popular one. Notice the way it's written. If you have something, you want to take a derivative of x to the n. So what you can do is bring down the exponent and subtract 1 from the exponent. For example, if I have a function that is x to the 4th, then the derivative would be 4x cubed. Right? You bring down the exponent and then subtract 1 from the exponent. That's it. All right, let's go on to these examples. Example A. If I take the derivative of 7, I get 0. The derivative of constant is 0. Here's a straightforward power rule, x cubed. So when I take the derivative, I bring down the exponent, which is 3, and then subtract 1 from the exponent. 3 minus 1 makes 2. Here. Derivative of y. Pi is a constant, so that's 0. Pi is not a variable. Now this one, you cannot take the derivative with our rules. Right? Notice in our rules, we don't have any fractions, so we've got to rewrite this without a fraction. So make sure you know your rules of exponents. So 1 over x squared can be rewritten with a negative exponent. Now I'm going to use I'm varying my notation just to remind you that they exist. Okay. So dy dx is the same thing as y prime. Now taking the derivative of x to the negative 2, I bring down the exponent, subtract 1 from the exponent. So if we want to rewrite this with positive exponent, it'd be negative 2 over x cubed. All right? Here, there's no radicals in our examples, right? We had a power rule and we had a constant rule, but no radicals. So what we're going to do is rewrite this as an exponent. If you recall, you can write a root as a fractional exponent, a rational exponent, with the denominator being the root, right? So it's 1 over 3. So now we can use the power rule. So it's 1/3 x to the negative 2/3, which would be 1 over 3 x to the positive 2/3 in the denominator. If they get really, finicky, that would be cube root of x squared. Right? Make sure you understand the algebra there. Right? That's algebra. I'm only showing one calculus step. Right? This is the calculus step. The rest of it is just algebra. Right here we have example F. I'm going to rewrite that as x to the negative 1/2. Right? It's negative because it was in the denominator. It's square root, so the rational exponent is 1/2. Put in the numerator x to the negative 1/2. Now I'll take the derivative. So it's negative 1/2 x to the negative 3/2. You're subtracting 1 from the exponent. So negative 1/2 minus 1 is negative 3/2. If we want to clean that up, it's negative 1 over 2 x to the 3/2. And if you want to clean up even more, that's going to be x cubed. What is it? Square root of x to the 3rd. But more than likely that is adequate, that one right there. All right, continuing. This is the constant multiple rule. In other words, if there's a number in the problem, what do you do with that number? Well, so rewriting this, x to the negative 1. So I'm taking the derivative, so just do negative 1 and just multiply whatever that constant is. So that means y prime equals negative 2 x to the negative 2, right? I did negative 1 times 2 gives me negative 2, and then subtract 1 from the exponent, and that's how I got negative 2 there. So that's going to be negative 2 over x squared. Next, here, just multiply the 4 times the 2. So it's f prime of t equals 8t. And the 5 just comes to the right. Nothing happens to the 5. Subtract 1 from the exponent. 2 minus 1 is 1. So I don't bother to write the 1. Okay. C, example C, y equals 2 root x. Again, rewrite that with rational exponents. So the exponent is 1/2. So y prime equals 2 times 1/2, which is 1. And x to the negative 1/2, because I'm subtracting 1 from the exponent. 1/2 minus 1 is negative 1/2. And that becomes 1 over square root of x. Right? I put in the denominator as x to the 1/2, and x to the 1/2 is the same as square root of x. Here is just negative 3/2. Right? The exponent is 1. 1 times negative 3 is negative 3. 1 minus 1 is 0. Anything to the 0 power is 1. So this is negative 3/2 times 1, but I don't bother to write the 1. Example E. I'm going to rewrite that with exponents. So that the coefficient 2 down there doesn't come up. Just leave it down there. And rewrite that as x to the negative 2/3. Right? It's the root that is the denominator of the rational exponent. And the 2 is the numerator. It is negative because I've taken it from the denominator to the numerator. All that is algebra. That is not calculus. Now let's do the calculus. It's going to be 1/2 times negative 2/3. I'm going to write that out because sometimes I get lost when I do that. And then subtract 1 from the exponent. So it's negative 2/3 minus 1. So that's negative 5/3. Now here, the 2's cancel. So I get negative 1/3 x to the negative 5/3. If you want to clean that up, it's going to be negative 1 over 3x to the 5/3. Make sure that negative is obvious, right? Sometimes it's hard to tell when there is a fraction, right? You can leave that alone, or you can rewrite it as negative 1 or 3 cube root of x to the 5th. I probably prefer this one, the fractional exponent. And here, derivative of this, it's just a constant, so it's 0. Okay, I'm going to stop the video here so you don't have to sit through the whole thing every time. All right, bye-bye.